Ever heard of New York Times? Possibly. But more importantly, have you heard of Svelte, the framework that originally started at New York Times by Rich Harris, who at the time was an employee of New York Times? It might have seemed like a journal like New York Times would be the best place for a developer like Rich to make a framework as powerful as Svelte. But when you're making the types of crazy data visualizations that New York Times likes to do, it starts to make a good bit more sense, because crazy data visualizations with thousands of points being scrollable and explorable on any device, computer or phone or whatever else, is a tough problem to solve. That's why Rich started working on Svelte. He wanted a good solution that took some of the learnings he had from other frameworks like React. He has a bunch of awesome talks about that. I'm sure they're popping up on the screen now. You should check those out if you haven't. They're all great. Computer Build Me an App is one of my favorite talks ever. But that's not what we're here to talk about today, because in order for Rich to make Svelte, he had to do a few things, one of which was heavily use React. The reason he was using React so heavily is because it's the framework of choice at New York Times. And that leads us to the topic for today. A very interesting piece of news that came across my plate. Just recently, the New York Times site upgraded to React 18, not 19, 18, and they saw some massive performance wins. So even though they're the house of Svelte, literally the place it was built, they're still using React, and they've done some very interesting things with it to make it performant, learning from their Svelte history, from other frameworks, and from what success and failures people have run into using React. And also, very fun thing, this article is published through Medium. Just thought that was funny. Anyways, let's talk about how the New York Times is able to meaningfully enhance the performance of their website using React 18. This is going to be a fun one. I'm actually excited. I know React 18 has a lot of optimizations, but I haven't seen them in practice at scale, and I'm actually quite excited to see how we got here. I also love the illustration of the glitched out, evolving New York Times logo. As software engineers at the New York Times, we place a high value on page performance, SEO, and keeping up to date with the latest technology, and also literally inventing some of the latest technology. So yeah, this isn't just some crappy press. This is very technically advanced stuff. And also, I don't think we appreciate the level at which SEO is essential to a business like New York Times. You lose entirely if you're not one of the first results that comes up when people Google things. For those of y'all who are old enough, you might remember AMP, the standard that Google pushed as like an alternative to HTML5 and JS to be served on your pages so that if somebody's looking on mobile, they can see a preview on Google slightly faster. The only people who ever consumed AMP back in the day were news sites, because they needed to compete with other news sites, and they were all fighting for any inkling of an SEO boost they could get. Yeah, it was an awful standard for doing these like embedded partial stories, and like you could click it and it would open up, all using these very specific standards in order to rank higher and make Google's life easier indexing things. It was an awful standard. It's entirely dead now, but the real ones remember AMP. So yeah, if you want to know a lot about SEO, talk to somebody who works in the press. They know it better than almost anyone else in the entire world. So I trust them when they say this. With those priorities in mind, the release of React 18 stood out to us as a significant and tangible leap forward in the ever-expanding world of web development. For our React-based sites, this upgrade promised a performance boost and access to exciting new features. Last winter, we set out to embrace the powers of React 18 on our flagship core news site. Along the way, we encountered some unique peculiarities, both in React and in our own site, that we had to learn to navigate through. In the end, we achieved big performance gains, and we unlocked a whole world of future improvements that we're still exploring. Before we dive into our process for upgrading, let's take a look at a few of the major benefits and changes in React 18. Smoother rendering with concurrent mode. Oh, concurrent mode, the most overused and weirdly shared thing. Oh, concurrent mode. I could go on a long rant about this. Let's see how they summarize it first, though. React 18 introduces concurrent mode, a paradigm shift that allows for simultaneous rendering of updates and user interactions. This translates to smoother animations, less screen jank and cumulative layout shift, and a more responsive user experience. 18 also comes with automatic batching and transitions. To take full advantage of concurrency, React 18 automatically batches state updates within a single render cycle, optimizing performance. It does so by breaking up tasks in the main thread, which is a big shift from prior mechanics, where almost all tasks were synchronously executed. The introduction of the new use transition hook also allowed engineers to ensure that certain sites will update without blocking the UI. Really fun point here. If you're not familiar with what it means by the states changes being batched, let's imagine that we have two use states in here. We have const a set a equals use state 0. Cool. We have 3 now. Import that. Kill all these. We'll show them all. Button on click, handle click. Cool. Use client that. Bad. React is hard. Okay. Cool. So now we have A0, B0, C0. And when I click, they'll get set to random numbers. So when they're referring to batching, what they're referring to is the fact that all three of these changes are happening within the same function call. So instead of A happening, then B happening, then C happening, the re-render gets held up until all three are done. If I was to console.log here, ABC changed, ABC, I go here, I console, we show here, it logs twice because React renders twice in dev. But when I click, it's only rerunning once, even though I made 3 state changes. If I wanted to show you how you can think of it working before, if I had a set timeout here and did the C change here, I'll even put a 0 for the timeout time there. You'll see a slightly different behavior when I click. It's logging twice now, and the first time it rendered with a 0, and then it rendered after, because putting this in a set timeout effectively pulled it out of this event loop. So when these other 2 functions ran, React knew, okay, this is a state change, this is a state change. Once all the state changes in the scope are done, trigger an update, and don't trigger the update until then. But since the set timeout didn't technically occur within this closure and within this function being run, it's being posted later on. I can even change the set immediate. Thank you for the reminder of that, chat. And it will behave the same, except React gets mad. The set immediate's not defined. Why are you lying to me? Don't lie to me, chat. Anyways, set immediate's not a thing for me, at least right now. So set timeout we'll go with for now. But yeah, the point I'm trying to make is that these are all creating a stack of changes. And since this is being put after this function call, after this event, when you call the set timeout, that means this will trigger another update later on. So we get the extra update here because this is happening. The way React used to work and the way a lot of other libraries work is effectively like you wrapped the set timeout for every one of these calls. Not that they're all being deferred, but when you call set A, it would re-render the component with A's data change. And then it would call set B and it would re-render it again with B's change. And then it would set C and it would re-render again with C's change. That's what's different with React 18 is when you have a pile of state changes happening within one function like this, they can be batched together and not trigger an update until all of them are done. Really, really powerful change. There's also exciting new features in 18 beyond these performance wins, including things like server components, server-side rendering, streaming updates, etc. All really cool stuff. The performance gains were particularly important to us because they promise significant improvements in our interaction to next paint scores. INP is meant to measure the responsiveness of a page, and it's the newest Core Web Vital, a series of metrics that Google uses to rank websites and search results. SEO scores are vital for a news organization, and improving our INP scores has been a difficult challenge for us, making this React upgrade a high priority and high-stakes initiative. Remember when I said that the biggest SEO hackers are news and press sites? See what I mean here? They're going to push everything as quickly and hard as they can just to make sure they get every ounce of potential indexing they can get. So how did they actually do it? Let's read about their migration process. The first step was removing deprecated dependencies. Everyone's favorite. Seems like they finally killed Enzyme. Oh God, that's so painful. Yeah, for those of y'all who are new enough, you might not remember the dark days of testing with Enzyme. Enzyme's really high on my shit list of Airbnb libraries I recommend staying as far away from as possible. Enzyme was a library for testing your JavaScript components, specifically for testing React components. You used it to fake a render of a given component in order to make sure it did what you expect. So you describe my component. It renders 3 foo components. So you have a shallow call to my component, and then you would check it using their helper stuff. So expect wrapper.find foo to have length of 3. The best part is that shallow rendering didn't actually use any of React's anything, so you would often not be able to actually shallow render. But then when you use the full render, everything was hell. It was rough. It was not fun at all. I had a lot of pain with Enzyme, and I've been very thankful to not have to touch it ever again since. Testing library is the recommendation now. Testing library started, funny enough, by Kent Dodds, another fellow content creator, and it has quickly become the go-to, not just for React, but for writing unit tests for UI on the web as a whole. Way, way, way better solution. There's no need to use something like Puppeteer when you're just making sure your component renders what it expects. Testing libraries, what ended up winning, and it won for a reason. Awesome that they were able to upgrade to it, but it sounds like they had to manually migrate all of their tests in order to do it, which is not fun in the slightest. In terms of time commitment, this might have been the biggest piece of the entire project. Enzyme was used in hundreds of test files across a repository. Only hundreds? Better than I expected, but there were thousands at Twitch. Moving off this would not have been viable. It required a significant manual effort as well as dozens of pull requests to fully replace it. We accomplished this effort over the course of several months with incremental pull requests in order to accommodate other product work and avoid developer fatigue. At the end of the effort, we definitely felt like experts in testing library React's API, and we're thankful to move on to the React 18 upgrade itself. Foundation setting, the second thing they had to do. Once the test files were handled, we could begin work on integrating React 18. In order to accomplish this safely, we first started by upgrading all of our major deps, types, and tests to conform to React 18 without implementing the latest features themselves. This involves simply upgrading everything from types React, React Test Renderer, React DOM, and testing library to the latest version in our package.json files and across our repo. Upgrading all major dependencies also involve refactoring some tests and type definitions to conform to the latest versions as well. And then step 3, turning on the engines. Once we felt confident in our package upgrades, we were ready to safely integrate the new functionality of React 18. To turn the features into reality, we needed to utilize the latest APIs, create root, and hydrate root. We have several instances across multiple web servers where we've integrated React hydration with a set of shared UI components rendered between all of them. So it was important for us to enable React 18 functionality in as many places as we could. At first glance, it looked as simple as changing references from React DOM.hydrate to hydrate root. Was it really? It won't be. But one thing I want to highlight here is that they were able to upgrade to React 18 relatively easily. Their issue wasn't that upgrading to 18 was difficult. It seems like once they upgraded their dependencies, they were pretty much good to go. There's almost no notes here about it at all. But then when they wanted to enable the new features, that's when the pain started. So if you're worried that React is leaving you behind, that you can't upgrade new versions because you're relying on these old things, you're probably fine. It's once you start adopting these new features while working on a giant code base, that things might be harder. But also, we have awesome articles like this to help you and your company ease your way through it. Unexpected challenges. As developers, it's easy to get overconfident when you hit the deploy to production button. Your end-to-end integration and unit tests are all passing, you've covered QA across various surfaces and devices, and you're moments away from getting the last feature out the door. We all felt that way when we initially deployed the latest version of React to the New York Times site. Soon after our initial deployment of the upgrades, we encountered a problem with some highly trafficked content, namely on a content type that we would call embedded interactives. Interesting. I was under the impression that a lot of these embedded interactive things were done through Svelte, not React. So I'm curious what they have to say here. So here's an example where they have a thing that's showing you how this cyclone for this major hurricane is traveling across the world. A custom embedded interaction built by our graphics developers. Yep, in the graphics development team, that's the team that Rich was on. So this all is making sense. At New York Times, we use custom embedded interactives, which render server-side using dangerously set inner HTML. These interactives have their own HTML, links, and scripts, and they all run independently of the React tree. Again, this is why they were using Svelte for it, and a big part of what informs Svelte's design. This allows the editors and journalists to inject one-off, self-contained visual and interactive elements into our pages without having to alter or redeploy core infra. Embedded interactives are the key to some of our most impactful reporting, but they can also pose real challenges for devs. A simplified example might look something like this. This is actually a really nice focused example. We have this embedded interactive string, which you might notice is just a string with this HTML, which has a document event listener added for this particular ID with server test. And now we change the content to be client. So on server, this gets filled with server. And then once it's loaded on client, it will be selected and replaced with client. Pretty sensical, pretty simple. Not something I would actually do, but it makes sense. And then you return the div where you dangerously set the inner HTML to that value. So now when it runs on the client, it can spin up the script tag and do what it needs to. I do this stuff far too often. In the setup, the script modifies the server test element's content from the server to the client after the page loads. This works because browser-rendered scripts execute before React hydrates to the DOM. It's essentially a black box where we trust the injected HTML and its scripts to behave as intended. How do we hydrate this though? This is where it's going to get fun. Enter React 18 with its stricter hydration mismatch requirements. If you somehow don't know what hydration is yet, you should go check my deep dive React server-side rendering video. It's an important concept. The quickest LTLDR here is we have an HTML page that was generated on the server, and now we have React coming in to take over. React needs to know what the button in the JavaScript code maps to in the HTML. So the way it does that is it reruns the same code that generated the page on the client, and it attaches each of those elements to the thing in the HTML already. But if when it's generating, it makes an element that doesn't perfectly match the one already in the HTML, it gets confused and it doesn't know what to do. That's what a hydration error is. The most common case for that would be if you have a page that uses new date and it renders that on the server, and then it calls the same code to render that on the client, but the client and the server are in different regions. Now the actual HTML content with that text that we built on each side, the server is going to have a different time than the client does. Even if they're in the same time zone, they're running at different times, so the result's going to be different. That's an important detail that often gets missed with the hydration stuff, is if the server and the client generate different results, that's when the mismatch occurs. So everything you can do to make that render as simple as possible is really beneficial. So in the example that they had here, even though the script tag was modifying the server test element before hydration in a hydration mismatch, React would discard the server rendered content and fall back to the client-side rendering, essentially nullifying the script's impact. In previous versions of React, even if there was a hydration mismatch, the React team opted to leave the version of the DOM in an invalid state as opposed to re-rendering it entirely on the client. And this is why they didn't have issues in the past. This is actually a fair thing. I didn't know this about React 18, where they changed the behavior, where in React 17, they would leave the old info. In React 18, they would nuke it in favor of the stuff that the client was rendering. I think that's the better behavior, but in a weird case like this, it's unintuitive. In practice, what does this mean? Well, when rendering the components on the client using the dangerously set inner HTML prop, any bit of HTML that contained a script tag inside of it would not run due to browser security considerations. This means that any embedded interactive that is re-rendered on the client due to hydration mismatches using the dangerously set inner HTML prop will essentially render as if the JavaScript had never been executed. In our example above, the text content will change from server to client, but on a hydration mismatch, it will re-render as server. This is a lot of info. I'll do my best to break down why this is actually happening. It's an interesting edge case I ran into recently. When you load an HTML page, like if we load this page, we check head. This has a bunch of script tags in it. If we scroll far enough, or I just Command F for script, you'll see we have a bunch of different script tags. These are all here when the page loads. If you add a new script tag to the page after the HTML has loaded, it won't run it. This is very unintuitive, and it's caused plenty of issues and plenty of things. If you have some JavaScript that then adds a new script tag to the page on the client side after the page loads, the browser doesn't do anything with it because that could be used to inject things far, far, far too easily. So because of that, what was happening here is the HTML being sent down with the script tag was getting deleted, and then the JavaScript would re-add it. But since it's adding a script tag after the page rendered, it wouldn't evaluate that script tag, so the stuff wouldn't run. Yeah. So this made their embedded interactive look wildly different from the expected render. Interesting. Yeah, it just didn't render the content because it was nuking it and using the server rendered content instead. Oof. Yeah, so their script tags were broken because of this. So how did they handle this? Given that 18 was significantly more sensitive to hydration mismatches than 16, we essentially had two choices in front of us. The first was to fix all potential hydration mismatches in our site. The second was to adapt embedded interactives to remount on the client as a fallback should a hydration mismatch occur. This left us in a bit of a dilemma. The New York Times had published millions of articles with hundreds of different components and tens of thousands of custom embedded interactives. Of course, we wanted to fix all of the hydration error mismatches that we had. So how can we do this in a safe way? In the end, we decided to tackle both problems at the same time. Extracting and executing embedded interactive scripts manually. I'm scared already. This will be fun. We know that script tags, when added via the inner HTML prop or during a client-side re-render, will not run automatically because of browser security considerations. So how do we get around this? Script tags will only run when manually appended or replaced as a child node to another element in the DOM. This means that in order to properly run script tags, we must first extract and remove them from the interactive HTML and then append them back in the right locations in the embedded interactive HTML when the component re-renders. So here's the function, or a rough idea of the function they used for doing this. So this replaces the script tags in the generic HTML with empty placeholders so they can replace those script tags in place later on client mount with the actual script. Oh God. Okay, so we have add placeholder, replacement text empty string, hoisted text, script text, replacement text, script ID, use the ID, we put the script counter, hoisted text replace. Interesting. So we are using these script tags that are being defined as soon as you load the page. So they have the right permissions to run. And then when the client-side code updates, instead of it just putting it in line in the HTML, it selects the specific existing script tag to update its contents instead. Because again, the rule is that the script tag can't automatically run unless it's there initially. It's not that we can't update the content of it. What an insane hack. This is the script that extracts and removes the script tags from interactive HTML strings, and then it returns an object containing the scripts to run on client and the scriptless HTML that has all of the scripts with empty script references. Insane. Absurd solution. They had hydration errors and they decided to become the water boy. Hilarious. So you might be asking, why not keep scripts on the server and then rerun them on the client? One reason why this is not possible in some scenarios is that some script tags declare variables globally instead of within a function closure. If you want to pre-render those script tags on the server and then rerun them on the client, you would encounter errors due to redeclaration of global variables, which is not possible. That's actually a very interesting point. They couldn't just rerun the script after having it there because you can't reinstantiate the globals the script expects to be able to run once. That's fun because if you were to navigate to a different page and navigate back, it probably would have broken as well. But JavaScript is hard. We all expect this. The initial solution fixed many of our embedded interactives. Unfortunately, not every interactive plays well with an arbitrarily ordered script execution. Here's where we navigate some nuances. Script load ordering. Some interactive scripts, when appended back to the embedded interactive HTML, must be loaded in the correct order. Oh god, this is going to be fun. Previous script execution strategies automatically assume that all script tags had already been declared and pre-rendered on the server. Now that we're stripping out those script tags and we're remounting them on the client, some inherent logic based on these principles is going to break. Let's walk through an example. Okay, so we have the script tag, const results, document.getElement, results manifest, inner HTML election results, and then we have interactive content, and now we have another script tag that has these election results as a global object that could be accessed, because we're getting the element by ID, and we're getting the inner HTML election results. Okay. In this scenario, we have an initial script that searches for another script tag by ID. Then it utilizes some existing logic based on the inner HTML of that second script tag. In the previous iteration, since script tags used to be pre-rendered on the server, there wouldn't be any issue referencing a script tag by its ID, as the script tag would be available in the DOM by default. Yes, as long as all of its HTML is there when the page loads, this earlier script tag can access things defined in this later script tag because it has access to the ID because it is in the HTML. But if you're adding these back later on, those guarantees go away. For optimal interaction, script execution needs to follow a specific order when reappended to the DOM. This involves the following. First, we have to append non-functional manifest scripts that contain static data. Then we have to execute scripts that have a source attribute with asynchronous next set. And then finally, we have to append and execute scripts with vanilla JavaScript in their inner HTML. Fun. This sequence prevents scripts from referencing each other before they've been properly loaded. Makes sense. The fact they have to do a prioritization queue for which script tags to reappend to the DOM is kind of insane. Let's see the actual performance benefits they got from all this, though. After integrating these very fine-tuned, almost surgical manipulations of our embedded interactive code, we felt that we were able to safely release React 18 into the wild again. While we would never be able to extensively QA nearly 40,000 custom-created embedded interactives, we were able to rely on a few reusable templates that the graphics team often returns to. This led us to validate specific behavior within our Svelte or our Adobe Illustrator-based embedded interactives. Oh god. In the long term, we're committed to squashing our remaining hydration mismatches and achieving complete peace of mind. But in the short term, we're ready to push the deploy button again. Once we released the new features and we spent an hour nervously monitoring internal alerts for more issues, we saw an almost immediate performance improvement. That's pretty sizable. Going from the 500 milliseconds to initial next paint down to under 350 is pretty nuts. That's a sizable improvement. And the median even dropped quite a bit here too. That's nuts. As you can see from the chart, the INP scores in the P75 range dropped by roughly 30%. Before the upgrade, one of our biggest challenges had been the frequent re-renders on our news site that would happen as the page loads. This caused a poor user experience as well as subpar INP scores when the user tried to interact with the still loading page. After React 18, our re-renders were cut essentially in half. That's kind of nuts. That's an insane chart. And people say React doesn't help everybody anymore. That's crazy. That's by just upgrading React versions, which admittedly to get these new features caused them some pain, but just bumping React versions cut their render times in half. That's nuts. These two very visible and important improvements are the direct result of React 18's automatic batching and concurrency features. This gave us a very clear and positive indication that we were moving in the right direction. Also note that the automatic batching and concurrency features didn't seem to break anything because there was no covering of that. The things that broke were the new hydration mismatch behaviors, not any of the performance wins. Historically, React's able to find these performance wins that don't break real code almost ever. This is also why things like the React compiler are so exciting, because you can run it on existing code, and 99% of the time it is just going to work and make your thing faster. That's awesome. React has to do that because they're used by Facebook on gigantic massive, unbelievably large code bases. So they care a lot about making sure upgrades don't just work on every code base, but benefit every code base. So it makes sense that they had a good experience here because as big as New York Times is, they are still smaller than Facebook. So where does New York Times go from here? The integration of React 18 has already resulted in significant improvements for us, opening the door to a wealth of previously unavailable possibilities. We're now focused on exploring the potential benefits of new features like start transition and server components. Our core intention is to continuously bring our INP scores down and improve overall functionality. However, we are mindful of questions that we still need to answer about these enhancements. For now, our primary commitment is ensuring the stable and reliable performance of the current React version we used. Apparently, they were able to upgrade other sites as well because they were so confident that the new site upgrade went as well as it did, and they saw similar performance gains. We were able to get our INP scores out of the poor zone before Google's March deadline, and we saw no negative SEO results when it became part of the search algorithm. We like to think that our readers are enjoying the slightly snappier experience, and our newsroom continues to put out powerful and interesting interactives every day without having to give their rendering framework a second thought. That's awesome. Shout out to Ilya for writing this blog post. This was awesome. It's really cool seeing the actual benefits that real sites and services and developers can have by just upgrading their versions. And if you're a dev at a company like this that's on an old version of React, give it a shot. You now have a blueprint on how to do it well. Thank you for sharing this information. This is a great article. And until next time, peace, nerds.